Good morning to all. Today I am discuss about the topic Simplex Method. Simplex method means the linear programming with the two variables can be solved graphically. The graphical method of solving linear programming problem is of limited application in business problems as the number of variables substantially large. The linear programming problem has large number of variables. The suitable method for solving is Simplex method. The Simplex method is an iterative process through which it reaches ultimately to the minimum or maximum values of the objective function. What's the concept for decision? Reductant constraints, multiple solution, unbounded solution, and infeasible solution. The procedure for Simplex method. Simplex method is used to solve problems having any number of decision variables, 2 or more. First, convert the problem to standard form by converting all the constraints into equal to type. For this, add a slack variables to the LHS if the constraint is less than or equal to type. Subtract a surplus variable and add an artificial variable to the LHS if the constraint is greater than or equal to type. For equal to type, the constraint also add artificial variable, the slack variables and the artificial variables, providing the starting solution in the Simplex method. Next one is construct the Simplex table by drawing two vertical lines and horizontal line. The top cuts the two vertical lines, the above horizontal line, and between two vertical lines write all the variables found in the constraint. To the left side of the left vertical line and the horizontal line, create three columns CB and B and XB. Against the CJ row, enter the coefficients all the variables found in the objective functions. Enter the coefficients of the constraints in the main body of the Simplex table. Under the CB column, enter the objective function coefficients, the current basic variable. For the maximization problem, the optimality conditions specify in Cj minus Zj. Okay. One problem using Simplex method to solve the LPP, maximize Z equal to 3x1 plus 2x2 plus 5x3, subject to x1 plus 4x2 less than or equal to 420, 3x1 plus 2x2 less than or equal to 460, 3x1 plus 2x3 less than or equal to 460, x1 plus 2x2 plus x3 less than or equal to 430, and x1 x2 greater than or equal to 0. Okay. First, by introducing the slack variable S1, S2, S3, the problem in the standard form is maximum Z equal to 3x1 plus 2x2 plus 5x3 plus 0s1 plus 0s2 plus 0s3. Subject to x1 plus 4x2 plus s1 equal to 420, 3x1 plus 2x2 plus 2x3 plus s2 is equal to 460, x1 plus 2x2 plus x3 plus 0s3 is equal to 430, and x1, x2, x3 greater than equal to 0. The initial iteration, then C1 column, the value corresponding 32500, CB column, then corresponding the row values S1, S2, S3, XP 420, 460, 430. The minimum value Zj minus Cj, first one is Z1 minus E1 is less than 0, the current base, the most negative is minus 5, the corresponding the pivot column. Okay. The current basic feasible solution is not optimal. The leaving variable, then the basic variable is 2 corresponding to the basic variable x3 end as the basis. Okay. Then first iteration replace s2 by x3. Okay. Then Zj minus Cj less than 0, that means again minus 5. The current basic feasible solution is not optimal. The leaving variable in the basic variable S3 and enter the variable x2. Okay. അപ്പോൾ x3 replace s2. That is the second iteration. Since zj minus ej is greater than or equal to 0, that means 4, 0, 0, 0, 2, 1. All the various variables values are zj minus cj is greater than or equal to 0. Therefore, the optimal solution is maximum z is equal to 1350, x1 equal to 0, s2 is equal to 100, x3 is equal to 230. Same model, the following problems. Okay, thank you.